Right. And I've unsoldered the connections, put my static wires in there because this thing isn't going anywhere. I'm not going to need to change out the wire. And I've screwed it into the holes that I had drilled. And that guy is sitting in there nice and flush, both sides, ready for case assembly. Now, I'll show you the back side. So those are my punches for the screws. Now, next step. This is the case. Again on the heat press fitting. These parts right here, those are steel nuts, just quarter inch coarse thread for mounting the entire thing onto a bracket or whatever the case may be. Those in Blender, the way I do these is I just create a cylinder. Shift A to create a mesh, and then create a cylinder with 6 sides or 6 vertices, and it makes a hexagon. You need a little bit of tolerance. With my printer, it's about 0.4 millimeters on a side because that's about how much the plastic bleeds over with my settings. But if you account for a little less than that, you push the part in a bit and it sits, and then I take another screw. Here we go. I take another screw, and usually a washer, but I'm not going to actually press it. I just do a washer so it doesn't mar the case. But then you just kind of screw it in. And when you get in far enough, even though the nut isn't set, you'll engage the nut, and then I'll take an Allen wrench and just run it until the nut sits down firmly. So I print with pretty high density infill when I'm intending to do stuff like that. Because if there's going to be load placed on the thing, and the nut has to not rip out of the bottom of the case. So this was an inset that was done for a logo. I'm associated with a company called Maneuver that we're making a motion capture glove. So this isn't related. This is my own thing, but I was kind of doing this as a demo to show my teammates. It's running a lot of the same software on here. So this is the audio router. So that's the inset for the microcontroller and the audio router PCB. All of the rest of it's just plastic saving. So up here, there's a corresponding. Let's see if I pull it. Yep, right there. So this next plate covers it, but there's these 2 holes right there for little LEDs. So when it fits over it, it's going to cast a light on the inside of that. That's transparent ABS. This entire casing, anything that's not metal or prefab was 3D printed. So that stacks on there. And here's a gasket. This is Flex PLA. That stacks on there, actually that way. And then on the top, we have another piece. So this is the top. That's the case front. So again, transparent ABS. That was modeled to fit a 16 element NeoPixel ring. That's a rotary encoder. This was modeled to fit one of those Adafruit 8x8 NeoPixel panels, hence the enormous power supply. So that fits in. Actually, it's going to go this way. That fits right in there. And I modeled all of the windows. No matter what you do, if you're 3D printing, every time you try for a square corner, you're going to have to clean it up. So usually what I'll do is in my model, everywhere where there's a sharp corner where a tight fit is demanded, I'll put a small cylinder and I'll have it run the length of the corner and I'll do a Boolean subtraction on it such that when Slicer gets to it, it tries to route the printer around the corner. And what ends up happening if you're good at it, you'll get what looks like a continuous corner with a nice sharp edge. It takes some practice to get it that good, but it makes fitting parts like this a lot less post-process work. But that's really tight, so I'm not going to bother, trying to fit that in there while I'm watching the video. But there are the LEDs, standard 5mm LEDs. These other cutouts here, these hexagonal cutouts, there are 8 of them for channel selection. So they're going to be conductive ABS, which I've validated that this works. I just have to print the part yet. But I'm just going to run a single wire into each of these holes, these 4 hexagons as well. Those are something else which I'll get to in a minute. But those 8 and those 4 hexagons are going to have conductive ABS, and I'm going to use the capacitive touch on the teensy to register button presses, and that's the only other user input. On the side of the case, the USB plugs in there, and that's for the power jack. Those are all audio jacks, but you can run it off of a computer if you like, but it's not strictly required. So this hole right here is for an electric microphone and breakout board with an amplifier on it. So that fits right in there. And now the thing can be aware of the sound, the ambient noise level. We figured it would be used for normalizing audio levels. And then this other window is another transparent ABS piece, and that's the case window for this. So it's another Adafruit part. This one is the logarithmic response, or I'm sorry, the linear response light sensor. So that just fits right in there, like so. And the case window goes over it, like that. And there you have it. That's what that's going to look like. It's going to be really bright, so the idea of the light sensor is to attenuate the brightness of the display based on ambience so that the user doesn't either fry his eyeballs or squint into it. So there we go. I'll get back when I've progressed.